Hello, and welcome to the Argyle AI Leadership Forum, Shaping the Future with Intelligent AI Solutions. My name is Michael with Argyle. It's great to have you joining us. A couple of notes before I turn things over to our esteemed speaker. First, a quick reminder to stop by our sponsors' virtual booths at any time during today's event and for the following week. Our partners are committed to providing you with valuable content and a great overall experience. At any time during today's event, you can visit their virtual booths from the main agenda page, which include complimentary materials, information, and meet and greet opportunities. To ask questions throughout the session, simply type into the Q&A chat, and we will address your questions at the end of the session. Also, be sure to subscribe to Argyle on YouTube for exclusive access to all our past events. And now, without further delay, I would like to introduce our speaker, Erhan Giral, Vice President, AI Strategy and Innovation with BMC Helix. We're excited to have Erhan with us for a thought leadership presentation titled Reset the Limits of IT, Running an Operating Model with AI. Erhan, thank you so much for joining us today. Welcome, and over to you.
Thank you, Michael, for the warm introduction. Hello, everyone. My name is Erhan. Like Michael said, I run a research and development team around AI innovation projects for BMC Helix. So I'm here to talk about some of the interesting things we have been seeing in the industry, as well as some of the cool things we have been working on. Obviously, our domain, IT, is going through a tectonic shift right now, right? The AI's impact, I think, has been already enormous, and we suspect this will compound and grow as in the coming short years. So it's exciting times to be in this business. We often say, hey, it's actually cool to be in IT again, because we always thought IT actually had a lot of potential because they're so close to the data, they're so close to the backbone of the enterprises that they support. So there's actually enormous potential IT teams can do to bring business value, to inform the organization better and make the organization run better. And we believe AI is just the right tool to accomplish all this. So I'm going to go ahead and basically talk about our experience in building agents to date, and also some of the industry trends we have been seeing. So with that, let me first talk about us a little bit so that you guys can understand the problem domain we deal with. So we are BMC Helix. Helix is essentially a platform, a data lake based platform that tackles what we call the service ops problem. So service ops basically means we like to offer automation and efficiency to organizations, to the enterprises we work with. And when you analyze an enterprise, these things typically comprise of three things. They have some sort of infrastructure, leased, owned. There's some computers and networking hardware somewhere, and then there's some software that they run to make the business function. And then there's the human beings. So essentially, from our perspective, an enterprise is essentially human beings that constantly deploy and touch IT systems on some piece of infrastructure. And our thesis is, if we have a good view of how the infrastructure is behaving, what the software is doing, and how these human beings are operating and touching things, then you have a very good understanding of that enterprise, so that you can offer automations and various efficiency gadgets. So that's our thesis. So for that reason, we have this is a target-rich environment. You can imagine there's a lot we can do. We look at the space as four big quadrants. So we have some agents and use cases that support service management business. So this is essentially what I just described. Running a IT service for the success of the business. And then there's AI ops. So these are your more technical, perhaps not your level 1, level 2 support, but these are engineers or people who actually know how the systems work and what's inside these containers that they're running, and so on and so forth. So these are more closer to the development role, site reliability engineers, DevOps engineers, and whatnot. So for those guys, we have an offering called service-centric AI Ops, and that offers a whole bunch of agents and use cases. We also have agents in security and compliance space, as well as enterprise service desk management features and agents. So what's coming? So there's a lot of agents being developed at various different maturities and stages, of course. But what's coming across all these agents is they're always conversative. So you can actually talk to these agents individually. They tend to create things. They are able to create plans of actions or new knowledge articles and what have you. They can summarize things. They can essentially basically talk about what they've been working on or what the status or overall picture of a problem or a piece of infrastructure, what have you, is. They can predict the future of certain trajectories that they track. That we have features around, oh, your such and such service is about to run out of disk space, and here's the the blast radius if that ever to happen. So we tend to do that kind of what I call strong prediction, not evidence-based prediction. And then we also do recommendations and automations. Essentially recommendations like what action, what is the next good thing to do to either mitigate and remedy that issue, or we also create automation scripts and whatnot. So those are the common grounds, or sort of like the common qualities of these agents. And we have a fleet of agents that tackle these different use cases. Our platform is a little unique in the sense that we are platform agnostic, in the sense that you can deploy us on Azure, Google Cloud, AWS, or our offering. We run ourselves as, of course, as a SaaS offering, and that's also deployed in OCI and so we are very I should platform independent. And most interesting, I would say, for generative AI features, we are also able to run our own embedded models, in the sense that you can take what I'll talk about and deploy it on your premise and run it. You run it in an air gap manner if you want, or have us run it for you. So there's a lot of options in terms of how you would run our systems. And for the user interfaces, I'm not going to show a lot of demos or anything today, but what we found works best for this age of assistance or tools like AI tools is, you want to go where the workload is, you want to go where the user is. And this is often for operational use cases. This is often your Slack channels, your Teams channels, your WhatsApp groups, so on and so forth. So it's actually sort of convincing people to come to the product so that they can get interesting insights from it. We actually go and deliver the insights just in time into the conversations that we actually track with the users. So anyway, so this is sort of who we are, so that you can understand the problem domain we are in. And where are we? We are in the we believe we are in the midst of a big tectonic shift. I mean, of course, you don't have to trust me to take this. You can look around. There's a lot going on in the AI space, especially in tangent to IT. And this is an information technology. Of course, we all know this, right? Changes, things that happen fast. Change is always a constant. We always say this, but now this time around, this has been a incredible boom. Like even the most progressives of us have been surprised by the adoption and the qualities of these new AI models. So back in 2025, we used to hear from our customers and prospects often, hey, does this really work? This sounds too good to be true. Show me, give me a demo. And of course, like everyone else did, we did a lot of pilots and POCs and whatnot. And everyone was worried about, am I using the right model? What if that model is better? And if you're technical, if you're in the domain, like everybody was wondering, okay, is there a better architecture for models, and so on and so forth. So we left almost all of that behind, because within the last 12 to 14 months, we have observed a step improvement in model efficacy, especially around software engineering tasks. And two things really happened. Models got really better. This last generation of Quens or Anthropic's Opus models, and now Fable, Gamma. I mean, they're amazingly capable software engineering models. And also the harnesses around these models got really, really good, especially the agentic scaffolding around the models also have gotten so good that we are now achieving over 80% accuracy in software engineering benchmarks. So this is just 14 months ago, this number was 33%. So now we are over 80%. And the difference is huge. So when it was, just last year, these were interesting tools that you can do like interesting, fun little projects with. But nowadays, you can use agentic coding for very complicated, long horizon, complex software engineering tasks that involves architectural design, user interface reviews, and so on and so forth. There's an explosive growth in efficacies and capabilities around software engineering. So one interesting observation to make here is you should ask ourselves why. What happened? Why did it get so good? In a nutshell, this happens because software engineering is mostly a verifiable problem. Meaning, if I produce a piece of code, it's not difficult to take that piece of code and then test it. Like, does it compile? Does it pass the unit tests? Right? You can, within seconds, you can test whether that's a good code or not. And Frontier Labs have been doing this. So they've been, profusely testing and learning, through reinforced learning tricks. They've been training their models in better and better software engineering because it is a very verifiable, quickly verifiable problem. We believe operations will be next. Operations are also, they also are verifiable. However, you can't verify operational claims or plans of action in seconds, but you can do it in hours, which means it will take longer for AI to figure the intricate IT systems that you might have. But eventually, we believe technologies like Helix will allow you to actually do that. So I'll talk about what that looks like. So what we have seen works for us is, essentially, you might be wondering, so how do I build an agent? These things are cool. Obviously, there's proof points that they work. Um, but then how do I get business value out of it? Especially, they're fun to play with. We all spent sleepless nights, I'm sure, working on, fun, interesting things with, open clause or what have you. But how do I get this work for enterprise? It's tantalizing the close, right? So in our experience, what works is you have to put your agents to real work under real pressure. Meaning, it's very easy to find fool's gold in this business, that you can really come up with very interesting POCs or demos that seems to work in certain scale. But to clear the bar of enterprise readiness, we believe what you have to do is you have to put these things right into production data, exposed to production as quickly as possible. And this is because, after all, we are building learning systems. And learning systems are extremely sensitive to the reality that they are exposed to, right? And learning, and I'll talk about this a little bit, learning is key to AI, meaning a pre-trained model. Often, when you go to ChatGPT and ask questions, it might tell you something like, well, what you're asking goes beyond what I was trained on, but let me do a Google search, let me do some web search, and then maybe fill up my gaps and then give you an answer. So if you notice, that means a model, actually, there's a cutoff date, right? So the model is trained, and then after that training, everything is, you have to pull into the context and then interpret just in time. So there's nothing model native from that point on. In the future, we believe that won't be the case. AI will actually quickly learn the environment specifics, the rules of engagement within the enterprise, what works, what doesn't, what could work, but it's actually not appropriate, maybe due to the cost or what have you, right? So there's a lot of intricacies in the business that constrain what these things should do. And we believe that is only possible through early exposure to real production data and also constant training of these agents. And I'll give you an example of how we go about that. So essentially, first step is go after the real data, from day one, day zero. And we also need to govern these things because am I getting value? Like, am I getting great answers, or am I getting okay, plausible answers? Right? In IT, how we measure this is, am I getting an actionable insight? Essentially, maybe I'm a bank. I know I'm having a hard time with a router, maybe a network problem. And if I go to ChatGPT and ask, okay, so how do I update the IP config, IP configuration of a Cisco 2000 router, ChatGPT will give you a response, perhaps, but is it actionable? Can I actually do that in my bank? Am I even allowed to touch that machine in that way, or is there any other team I need to engage? Right. So there's a lot of actionability tests that the system needs to pass before we can say, oh, I got value. So how do you measure this? So we recommend do what we do, essentially log everything into an auditable surface, persistent system. You can maybe let the autonomous steps run autonomously. Sorry, read only non steps autonomously. But of course, keep the human in the loop. But every decision point that the human makes, or what you propose, what then they uptake or don't, has to be recorded so that you can look back and say, okay, so I've done better with this release versus the past release. So you essentially have to establish KPIs around the governance from the day one. Otherwise, you'll never know whether you're saving money, whether this thing whether it works or not. So it's important. You kind of have to think about governance from day zero. Another one last thing that works for us that we also recommend is you have to keep the feedback and store that feedback as gold, because when a human being spend time to interpret the results or claims of an AI system, that's important. That's golden. That has a lot of value. Because human beings are very expensive, right? You can't task them with thousands of batch calls. So whatever feedback you get from them becomes very, very important, and you have to create a flywheel of learning from their feedback and actions. And often that in our in IT world, people don't like to give feedback, right? They're busy, they don't have time to type things and tell things. They just walk away. What we do is for instance, we look at the ticket work logs. We look at especially maybe there's a problem. We give them a plan. Okay, so go do these. And then if they don't do those steps but follow other steps, once that ticket is closed, we track all that and we go look back and say, oh, okay, so we give them a plan, but they only followed half of that plan. So let's see what happened. Let's create a reward system so that the system can basically make better and better recommendations based on the feedback we are getting, implicit or otherwise. How do we essentially how do we apply this to the IT operations space? Is little nuanced. We have a composite AI platform, meaning we don't just take telemetry data from your computers or your data center and then just feed that into the model. That just doesn't work, because models have for two reasons. Operations data is often very voluminous, right? So when you look at logs of a complex system, that's typically gigabytes a day, right? When you're thinking about time series, metrics and whatnot, that's sometimes billions of them from one environment, right? So it's a voluminous, it's a sparse data set, as we like to call it. So something needs to essentially reduce the noise, normalize all that, create correlations and causal relationships between anomalies and whatnot, and that takes a bit of time and essentially a data funnel that prepares that observability machine data for the agents to then consume. But once you do a good job of that, then you have a beautiful system, because now your agents can start from very grounded observational data. right? Because there's in IT, there's really two things of looking at two perspectives on a problem. You can look at what people are saying about that problem, right? When you look at the tickets, when you look at the ticket descriptions or work logs, you'll see operators or users complaining, oh, the web, the login page is very slow, or I couldn't log in today. So they're describing uh, their experience in human language. So that's one perspective of the problem. But if you flip that problem and if you look at it from the machine side, you'll see, oh, there's 404s going. All of a sudden in your logs, there's a whole bunch of authentication problems because maybe the IDP wasn't reachable or what have you, right? So there's a machine perspective and a human perspective. So what we try to do is we try to bring these two perspectives together into a cohesive picture and then really find out what's going on. So anyway, so for machines for agents to reason and work on this voluminous operational data, we had to do a lot of other types of AI to sort of compress and dedupe and denoise all that first. However, once the agents get, like I said, a good context of what's going on in the system, what has happened in the past, like a very good snapshot of that problem, then they can actually, in our experience, they can be extremely accurate and actionable. So right now, in the way our product works is we still require human approval for any change type of action that these agents might take, and so that's where we are. So the and when you are so this does require a bit of a trust, right? So you have to essentially expose a lot of machine data to these systems. So and for that reason, our model of hey, you can host the model yourself, in an air gap manner, actually works well for some of the organizations we work with. And while, of course, everyone wants their AI to learn and adapt as the organization changes, we have tenant isolation in the sense that any sort of learning is isolated to that tenant. That's another because a lot of operational goodness, the tribal stuff is actually part of the IP of that business. So a lot of organizations are quite sensitive in keeping that private. So I'll give you one example. So that it's not boring. We have a lot of agents, but one of I think I would say most interesting one that we are working on is called a root cause analyzer. So root cause analysis is of course a very old durable problem, right? Ever since we had computers, something has been going wrong with them, and people wanted to understand. Okay, so how do I get this up running again? Because my business depends on it. So the way this works is it takes a lot of telemetry information from various different monitors you might have, like AppDynamics, Dynatrace, New Relic, or what have you, or SolarWinds, or essentially we tap into where the observation data is, and then we start pulling some of that data out either as streams or in an agentic manner to understand, to understand what's going on first, what the impact is, whether something should be done about it, and what the plan of action is for that specific root cause. So with this, this is actually deployed in a few places now. Most advanced deployment is, of course, in our own operations team that basically babysits our own operations. So here we are actually seeing MTTR, mean time to resolution, to go down from over 4 hours to 90 seconds in a lot of repeating cases. So that's remarkable. I mean, it's an astounding number, no matter how you look at it. But it's not difficult to explain because what used to happen between a NOC, an SRE, and a database engineer. First they need to find each other. They need to get into the right context of discussing the problem, right? There's a lot of practices that people created around war rooms or Slack channels and whatnot to do this sort of troubleshooting. But it happens at the speed of human communication, which is not very, very good always, right? The thing about agents is, once they have access to data, Now we are talking about nanoseconds at times, to pull the relevant data out. So the machines have enormous advantage in terms of crunching, reasoning about these issues. So right now, like I said, our product does root cause analysis. It says, okay, so you have this problem here. Here's the machine that you need to focus on. Here's what you need to go and do on this machine. So we also have some prototypical agents that run as command line agents, such that when the operator goes to that machine. So this is actually a sample from a real production environment. So what we say is, oh well, you had a situation, you had a bad thing going on. Go log into this machine to fix it. And once they go log into that machine, they use our CLI agents, and then that CLI agent does additional diagnostics, proposes a fix, waits for the approval, and then fix it. And in this case, in this particular example, it took about 42 seconds in 9 steps. So this is quite remarkable. This is, really, really cool stuff. And we believe the operational tasks will be within the grasp of AI. More and more stuff will fall into this category, and we will automate quite a bit of work from this type of, hey, let me troubleshoot the issue, or let me mitigate the issue for now. Maybe I can fix it later. And this is essentially your NOCs, your SRE teams, some DevOps teams, and so on and so forth. All right. So the going back to our story of how we build something like this. Like I said, go to the production data immediately. So every week we repeat these experiments. So for instance, this is from a couple of weeks ago now. One of the tenants that we participate in this design partnership. So they had about 14,000 requests. So these are different requests that made it our generative AI through 15 different use cases. We measure the success in terms of, first of all, did we produce a coherent result? What's our average response time? But if you are going to measure your agents as digital labor, this is the sort of thing you have to start thinking about. Okay, so what's the volume of this? How do I essentially you have to treat them like almost like a human. Like, I hired this guy, is he doing his job, or what needs to be, what needs to change here? So we have a system that, like I said, it goes beyond the pre-trained capabilities of the model. So I won't have much time into going into this, but I'm sure you heard, DeepSeek, or some of these reinforced learning labs that sort of made pretty interesting breakthroughs within the last year or so that allowed these models to sort of think, internal have internal trains of thoughts, if you will. So with reinforced learning, you can actually influence the way these models reason internally. So that's quite interesting. So what we did was we created a flywheel, if you will, so that when an incident is resolved, where even if the operator doesn't give us feedback, we actually go back and study that incident, like what was done, what conversations they had, who did they talk to, did it work, did it not work? So we sort of look at the entire work log, all the emails, all the conversations, all the attachments about that case, to see if they did something that we didn't catch, or if they did things that we recommended them and they follow. So we actually do a very deep post-mortem of these tickets to understand how the operators really reason about the problem, so that I can take their reasoning trace and then teach my model how they reason about it, so that they can so that my model can reason just like them. And this works. So this actually gets better and better as more tickets are opened and closed. So there is an interesting trend also going on in the, right now in the industry that you might be interested in. That's the cost. If you notice, the cost of frontier models are exploding right now. I mean, Anthropic went up by 35-40% in April. OpenAI doubled. In fact, Anthropic just yesterday released Fable, and Fable is almost twice as expensive. So it's really getting expensive out there. If you think, oh, there's just one model that I'll use for everything, that's becoming unreasonable. So that's why our strategy around, we have a strategy to use smallest possible model for the use case, and we do that. So we have parameter efficient, fine-tuned, small domain specific models that allows us to do all this in a mixture of expert architecture. And with that, I'm right now today I'm 10 times cheaper than the cheapest frontier model. This includes, by the way, Chinese offerings, or up to 150 times cheaper if you compare me against the OpenAIs and whatnot. So we live in a very different cost parts of the cost curve. And we also run these models on commoditized, older GPUs, so that I don't really need a massive GPU cluster to run on any of this. So we run on single card. Essentially, you can run this model on your recent MacBook in pretty good, like 50-60 token per second capacity. So these are important. It's actually I think in 2026 you'll hear this more and more. Frontier will get more and more expensive, but you will see that these open source smaller models that are designed that are fit for the purpose, that are designed for a purpose, will actually gain a lot more traction. There's NVIDIA also talks about this. OpenAI sometimes talks about this. So domain specialization of these models creates a lot of efficiency. So I would like to leave you with that also. And then how do we govern, when we are thinking about these agents? The way we do it, in our agentic coding initiatives, obviously we use these agents in our software engineering too. We always tell people, okay, so if your agent breaks it, you own it, so there should always be an audit trail back to a human being, so that human being can oversee all those activities still like we used to. So it's important to have it's important to have human beings still responsible. So that's why we always take their approval before we do big things. And also, I would recommend whatever agent you're building, make sure think about the observability and governance of that agent very, very early on, so that you can understand whether it works or not, or whether maybe you're paying more money to the digital agent than you would be paying to a human. So all those calculations don't matter. And also, isolation and sovereignty is kind of important, because you're sending very intimate details about your IT organization to someone, to OpenAI maybe, or Google, what have you. Sometimes this is appropriate, sometimes it's not. So it's important to think about that based on the domain you are in. And in our case, we also have to align with a whole bunch of regulatory pressure, especially from the EU. So follow these. These are really important. They are people are trying to figure out how to guardrail and govern these AI systems. I mean, you might have different opinions and philosophies on this, of course, but if you are in the government software business like we are, these matter a lot. So that's another data point I would like to leave. And finally, the recipe that seems to work for us, that what we see is, first, if you're building agents like this, consolidate your operational data plane. I mean, the old adage of garbage in, garbage out is still true with these things. In fact, with generative AI, if your data is not good, I mean, they'll go crazy. They'll never stop generating and convincing you. So it's important to have that data cleanliness and conversation at first, and have a good data practice. So Helix does that very well. Our platform is all about deduping, associations, and modeling data. So so there's a bit of that you'll have to do. And how do you start? The IT is a target-rich environment, right? So what we do is we interview ops teams and ask, okay, so what do you do all day? What's your most repetitive job that still requires you to do analytical things and whatnot? So you sort of have to measure where the total human pain is, so that you can apply AI to that area and then extract that digital capacity back and do other things with. So that internal reflection of analysis of who does what, what do you do all day? Those conversations are very important. You have to be honest with yourself. On the number three is essentially, it's very easy to convince yourself that, oh my god, this thing is great. You always have to put these in measure like an employee from day one, and don't be nice. that's very important. And also at the stage we are in, approval gates are super important, because you're going to give access to maybe a production system to these things, right? Things can go swimmingly, but once they don't work, when you have a problem, you need to be able to audit that and roll all that back, and you have some governance and some systems that allows you to do that, of course. And then fifth point I would like to leave with you, I think is important, is you don't really have AI unless it actually learns. So the learning part of AI is very important. And all these generative models learn through text, right? They consume all the text that's available to them. But what we found and what the recent research shows is, when you expose these models to the real world, where they can actually learn from their actions and their consequences, they do amazingly well. And that's actually what we do in our labs today. So we expose these root cause analyzers and remediation agents to real problems, and then have them actually, go break things, learn from that, try to remedy it, right? In a closed loop. We constantly show the model what works, what doesn't, what partially works, what works great, and create that. So your job in life is now essentially to come up with that reward function. Like, how do I reward the right behavior of my agent so that it learns the right behavior? And we have a lot, we have frameworks and systems that does this for the IT domain. So before I ask for solicit for questions, what I can leave you with is, if there's one thing I can leave you with, model capability as far as IT is concerned is solved. Like, we don't need to wait for better and bigger models to really do great things. The models of today are amazing. If you haven't played with them within the last, I would say, 3 months, give it another shot. They're really cool. However, to make these models profitable and economic and actually meaningful, there's still work to be done. And we believe the operating model, the way you govern and source data and train these models, is the differentiation now. Models are quite commoditized. From our point of view, they're almost interchangeable. In fact, they are interchangeable. This covers frontier, Western, and Chinese. They're interchangeable. However, getting something done and create efficiencies for the business is still an unsolved problem. So like I said, our philosophy is deploy right away to real environments, and don't hang up on just demos. Deploy at scale. You have to be very measured and disciplined around their efficacy and their cost and whatnot. And they need to get better. If your agent essentially is not getting better from getting something wrong, you'll quickly disillusion your users and they will walk away from you. So with that, I would like to hand it back to you, Michael, and you let me know if there's any questions or discussions that we want to dig into.
Thank you, Erhan. This was a wonderful thought leadership, and we appreciate you. Unfortunately, we are over time on this session, and so we'll have to get going.
Okay.
Not a problem. This was wonderful, and we really appreciate you. I'd just
Thank
like to
you.
thank all of our audience members for joining us. Now, this session, along with all of today's content, will be available on demand following the event. And as a reminder, please be sure to check out our Our next session, which will join in just a few minutes, this will be a keynote presentation titled Preparing the Enterprise for an AI-Driven Future. Please remain on the stage. The next session will begin automatically. We look forward to seeing you there. Erhan, thank you so much.
Thank you.